Hello and welcome to this Dr. Frost Maths video on simultaneous equations for Key Stage 5. Now in the Key Stage 4 video on simultaneous equations we explored linear simultaneous equations as well as quadratic simultaneous equations. So we're just going to recap it with a few example A-level problems here. And I won't cover the linear ones here, I'm just going to cover quadratic simultaneous equations. So let's dive into these two questions here. We want to solve these simultaneous equations. And just as a reminder, simultaneous equations is where you have multiple equations with multiple unknowns and you want to find the value of both of those unknowns or three unknowns at the same time. And we can't use elimination here. And by elimination, that's when we add or subtract the equations. Because if you either added these or subtracted these, because that's an x squared term and that's an x term, they won't cancel in any way. So we have to use something called substitution. And the way you do it is to do this. You rearrange the linear equation to make either x or y the subject. So in this particular case, the linear equation is the one without the squared, so it would be this equation here. So let's do that. We want to rearrange this to either make x or y the subject. Now it's much easier to make x a subject here because then we won't have to divide by 2. So we're just going to add 2y to both sides. So if we do that, we have x is equal to 1 plus 2y. We added 2y to both sides. And then what we do, so that's step A, and then step B is to substitute into the other equation and then solve. So if we do that, we've got x squared plus y squared is 29. Let's just write that out again. We're going to substitute that x for 1 plus 2y. So let's put that 1 plus 2y in brackets all squared plus the y squared is 29. And then we just need to expand and solve. So if we expand this, remember the quick way to expand something squared is to do the first thing squared plus, and then you do the product of these two things doubled. So 1 times 2y is 2y, doubled is 4y. And then this second thing squared is 4y squared plus another y squared is 29. And now this is a quadratic, so we want to get everything on one side and collect like terms. So we've got 5y squared, we've got that plus 4y, and then we want to have 0 on one side, so we're going to minus the 29, so 1 minus 29 is minus 28. And then we're going to factorise this. And in fact, we could just use our class whiz or the old silver calculator to factorise this for us, or solve it for us. So if I just go to equation mode, and we put the 5, the 4, and the minus 28 in, and that's going to give us solutions of y is equal to 2, or y is equal to minus 14 over 5. And now that we've found the y, we can find the x value corresponding with each of these y values. And it's easiest to just substitute it into your rearranged linear equation. So x is going to be 1 plus 2 times 2, 2 times 2, so that's 5. Or x is equal to 1 plus 2 times minus 14 over 5, which is minus 28 over 5. And if I just do that on my calculator, we get minus 23 over 5. Now this second question is a bit more difficult. So the sketch shows curve C, that's the curve, with equation y equals 3x minus 2 root x, and the line L with equation y equals 8x minus 16, so that one there. The line L cuts the curve at the point A, so that point of intersection. Use algebra to determine the coordinate of A. Now do you remember that when you draw the line associated with each of these equations, then the point of intersection is basically the solution to these simultaneous equations. So we just need to solve these simultaneously. So we've got y is equal to 3x minus 2 root x, and we've also got y is equal to 8x minus 16. So we can apply the same steps as before. We firstly rearrange the linear equation, well that's the linear one and y is already the subject, so we can just keep it as it is, and then we substitute that into the other equation. So that y in the other equation we can substitute with 8x minus 16. Now the reason this is harder to solve is it's not exactly a quadratic. It kind of looks a bit like a quadratic, but instead of like x and x squared, we've actually got root x and x. Now if you have that combination in the equation of root x and x, the easiest way to do it is to make a substitution. So let's just say let p equal to root x. I've just chosen a letter that's not y because we've already used y here. So if we then sub that in, we can see that if we did p squared, that would be that squared, which is just x. So now we can rewrite this in terms of p. So we've got 8x, so 8p squared minus 16 is equal to 3p squared minus 2, and root x we said was just p. Now this is a quadratic at this point, so let's just put everything on the left hand side because that's where we got the most p squareds. So minus a 3p squared, we got 5p squared. Add on the 2p to both sides, plus 2p. And then we've got the minus 16 equals 0. And again, it's totally legitimate to use your quadratic solver here. So I'm just going to put in the 5, the 2, minus 16. And that gives you p is equal to 8 over 5, or p is equal to minus 2. But we said that p was root x. So either root x is 8 over 5, or root x is equal to minus 2. Now, when you square root a number, you can't possibly get a negative number, so that we can rule out. But if root x is 8 over 5, well, we can square both sides to find x. So x is equal to that squared, which is 64 over 25. And then from that, we can then use this equation here, or either equation, to find out what y is. So y is just 8 times x minus 16, and that gives us 112 over 25. So that's the coordinates of the A. If I actually write that as a coordinate, we have 64 over 25, and we have 112 over 25, and that is the answer.